In this video, we are going to create a simple compiler using React. But first, let's have a quick look at what a compiler is and how we are going to build it. A compiler is a type of computer program that converts code from one programming language into another programming language. Let's go through it in detail on Executor. As you can see, this is the structure of a compiler where there are 6 phases and the input from the source language passes through all these stages to become a target language. These are lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, and finally code generation. 2 additional concepts, error handling and symbol table, are also associated with each phase. Now here's what we will do in our project. We will create a tokenizer for lexical analysis. For syntax and semantic analysis, we will have a parser. For intermediate code generation, optimization and final code generation, we will use a code generator. For symbol table handling, we will use our token spec container. And finally, we will have an executor to run all these steps together and show that our compiler is producing an output. Let's take a quick look on the project setup. We are working with React plus Vite. We have a home page that contains the compiler demo component. It already has some default outputs and a simple tool layout with 2 sections, input and output, and 3 buttons. Depending on which button is clicked, the tokenizer output changes. And we can also edit the input code in the window. As you can see, the sample code produces some default output related to boilerplate. Now let's start building our project by creating the tokenizer. In the components folder, create a new file named tokenizer.jsx. Then create a function tokenizer that takes input as a parameter. Inside it, create a constant tokens. This will contain all the tokens in future. But before moving further, we need to define all the tokens that our compiler will accept. So create a folder named constants and inside it, add a file called tokenspec.js. I copied this from a source which I'll share with you in the description, but you can also create your own. This follows JavaScript's regular expression or regex syntax. You can see the definitions for literals, keywords, identifiers, etc. You can specify your own rules as well. There is no strict limitation here. Now go back to the tokenizer function. Import token spec from constants/token spec. We will set a variable code to the input, and while the code length is positive, we will process it. Let's create a variable match equals to false, which will track if a substring matches any rule in our token spec. We will use regular expressions to find matches. If there's a match, we will create a token and check its type. If it's not a white space, we will push that token into our tokens array. Finally, we will slice the matched part from the code and continue until all code is tokenized. Once done, export the tokenizer function. Now let's import this tokenizer into compiler demo.jsx. After successfully importing it, we will modify the default output handling with an if-else condition inside a try-catch block to check which compiler phase is active. Let's create an empty variable output. If the phase is tokenizer, we will call tokenize code function and output the tokens. For the parser phase, we will temporarily display a simple placeholder output until we implement it. And for code generation as well, we will add code gen and finally the error handling to handle any error if happens. Let's check for any error. If you see this error tokenizer not found, make sure you to import it correctly. We have to use /tokenizer instead of the compiler folder since it's not in the compiler folder. Let's see on the page, inspect, outputs is not defined in compiler demo. Okay, line number 61. These outputs are phase, but we are using output as a simple variable. Okay, this must be working now. Yeah, we can see the compiler, but here it says regex.match is not a function. So we will have to go back to the tokenizer and replace this .match with .execute to properly execute the regular expression. Okay, as we can see the JSON response now as output for our tokenizer. As we can see, when I type a variable name, it is identifier, and any symbol this equals to changes to equals. A new element in the JSON is added with each token added, as you can see, plus 6. This is how the tokenizer works. Now let's make basic changes to make it more visually better. So the output is in JSON response. I'll change that to simple map with passing t.value and t.type. Okay, attach a end line to each. Now much better. As you can see, there's all the individual tokens are adding a new line. It is good. Let's add a for loop to check if the tokenizer is working fine. It is not accepting some of the symbols like the simple greater or less than because we have not added it in the symbol table. So that is very important step. We need to know what symbols we are going to accept. So we will have to add them properly in the symbol table. And let's fix this UI. As you can see, build your compiler is failing. Just a few second task. Go to the component and add a margin at top. Add 10 VH margin. Okay. So the margin is breaking the component. Instead of margin, add internal margin. So padding top 10 VH. As you can see, much better. Before we start building the parser, let's quickly understand what a parser actually is. A parser reads the list of tokens produced by the tokenizer and checks whether they form a valid structure according to the language's grammar. It builds something called an abstract syntax tree or AST, a tree representation of your program that shows what's happening and in what order. Think of it as a grammar checker tool for your compiler. We will learn more about parser in the upcoming video, but first let's start with the basics. So we need to create a file that will contain all the node types we are currently creating in the tree structure for our AST. So create a file node types.js in which export const equals to node types. This will have all the different types of node for the AST. We are having program, variable declaration, variable declarator, identifier, numerical literal, binary expression, call expression, expression statement, print statement, and one last, literal. This much is enough for now. Now create a file in the components folder, parser.jsx. In this file, import all the node types we created. Okay. Then create a function called parse with tokens as input. Okay, so let me explain how parser works conceptually. The first part is recursive structure matching. We will create functions, parse expression and parse statement. These will have recursively calling each other for parsing the program we have coded in the input. Then we have predictive look ahead, the peek and consume function. Peek means to store the next token in the program, and consumes moves the pointer from the present unit to the next unit. The third step is operator handling. We will have to define how the operators will work, and in higher level we will create operator precedence and associativity. Then statement construction, statements like let x equals to 5 or print something. This will be in the statement. And finally, fifth, program node. All the past statements are grouped under a single top level node named program. Consider it as a root of the tree. And whenever we need to execute the program, we will just call this program head, and this will traverse the whole tree and create the logic of our program and implement that. So let's get back to the code. Now it will be quite easier for you to understand the code. A function peek to return the current value of tokens, then a function consume to store current value in token and check the token and token type. If the token is missing or it's not of type, we will throw an error. Otherwise, we will increase the counter by 1. Then we are going to create functions for our programming language. This will have the logic of how our compiler works. So a simple parse expression function, a token to store peek, then check the token if it is number, return its type number. If the token type is identifier, then consume ident and return this type and name of the token. Throw error if any token type mismatches happen. Then for operators, we are creating these 4 plus minus star and slash. Create a if condition to check for the operators and the left right precedence according to the binary expression, which we will define later. Parse binary expression. Okay. Then a function to parse a statement. So we are using let keyword to create a statement or assignment of some constant to a variable, and then a print statement. For the structure, we are using print parenthesis statement and then again parenthesis and finally a semicolon. If this is the flow of a line, it will be consumed. Otherwise, it will raise an error, or like if the semicolon is missing, it will raise semicolon and all the other required errors. Then a program node for the parent node. This will be of type node types program and its body will be empty. While current is less than tokens.let, we will push all the parse statements into the program and then finally return the program. Okay, so parse assignment is not yet used. Let's just comment it out for this moment and check if our code is working or not. Let's also parse a binary expression in the print statement so we can see an output on running a binary statement a plus b types. Then go to the compiler demo.jsx and import the parse. This function will parse our tokens tokenized in the previous stage. Import parse from parser. Now change the statement of the parser commands in the else if. Let's first simply run this output and we will change that later. Node types error. Okay, so this is some calling error. Go back to the file. It is not in the same folder, so type dot dot slash to root back to the previous directory, and after that the constants folder, and inside it node types unexpected token for. Let's create a simple print statement according to our programming scenario. Print parenthesis whatever, then parenthesis close and semicolon. As you can see, a JSON node is created. This is how parser works. It created a node for the larger node is program node, and inside it you can see the print statement. So in the updated UI, we can see the nodes as a simple tree structure instead of the JSON element. Let's try to write some code. Okay, so it is assignment issue with equals. Variable declaration. Okay, this is working fine. Now we will move to the next part, code generation. It is like a translator which have a predefined conversions of source language to target language. For every node we will add them in switch cases and define function on them for target language. In real compilers, this is actually a complex procedure of 3 stages. First is intermediate code generation. This is what we will be doing in our compiler. Second, code optimization, removing redundant code, dead code elimination, improving efficiency with reduced memory usage of the program. Third, code generation, generating program in target language, usually in assembly or some higher machine level language. Let's code the code generator. So we will start by creating the file codegen.js. In this, we need to import the node types we created earlier. Then we will create a function called codegen which will take input as a node. Now start creating the switch case where the switch is of node type and all the cases will be node types dot value, like for program node types dot program, and then node types dot variable declaration. This will return the code as let node dot identifier equals to codegen node dot init, and then number literal. This will return the node value. After that, node types dot identifier, it will return the name of the node. Then assignment expression, in this case it should return the right value assigned to the left value. Okay, so let's first create binary expression instead of that. The binary expression is left value, then node operator, after that the right value, after that the assignment expression, the right value assigned to left value. Okay, so there is a typo in literal. Let's rename this to number literal instead of numeric literal. Okay, then get back to the code and create a default case. This will return unknown node type if the node type is not found. This is completed. Now we will import this function in the compiler demo file. So repeat all the 3 earlier stages, that is tokenizing, then parsing. After that, we will create the JS code using CodeGen, passing the abstract syntax tree created by the parse phase, and we will then output the JS code. And finally import the CodeGen component. Okay, let's go to the compiler and check it. As you can see, the assignment is as it is and the print text is converted into console log, which means it is generating the simple JavaScript code. We can add more depending upon the target language defined by us. Right now it is JavaScript, so console is enough. After that, I am going to create an executor file that will contain the process to execute all the code we have generated in JavaScript. So we can see our compiler working on the page. So create a function in the executor.js file, execute, that will take JS code as input, and let's create an output array, and then const original log equals to console log. This will be the function for original log. Inside this we will push our message, and for each arguments use spread operator by 3 dots, and then push the arguments in the output array, and finally catch for error, and in the end return the console log with original log. Okay, now we will call the new function with JS code as input. This will run the function, and finally we will get an output in the output array, and we will return it. Now go back to the compiler demo file, and we will have to create additional if for this execute feature. Repeat the same steps like tokenization, parsing, and code generation, and then the output will be in the execute feature. Now import execute from the executor. Since we only created 3 buttons earlier, so we will need to add executor button as well in the compiler. So move down to the HTML component. Here you will find an array containing 3 buttons which is mapped below it. So add another element, execute, and okay, so cannot import from executor. Let's see what is the issue. Executor. Okay, there is a spelling mistake in the file name executor tor. Okay, now you can see this execute button in the window, and when I click on execute, you can see the output. When x is 5 plus 3, then output is 8. The print is working fine. We change to 7, the output becomes 12. Let's change another value to see subtraction. 12 minus 6, then 12 minus 3. All the phases are working fine. Let's test another variable. Let y equals to something ABS. So you can see ABS is not defined. Looking for string. Okay, so we cannot yet define a string. That is the issue. As we given it a value 5, it created output. So that is how we built the basic version of our compiler. All the project is set it up. You need to do more research about compiler and have a good logic building in writing codes, so you can create another functions. What I suggest is create for loop and while loop, or even an if condition by yourself, and see if you could build it. and if you could not, comment down. I will either explain that in the comment or make another video improving the quality of our compiler. Also, if you think this is not practical, you can create all the JavaScript files and bundle them and utilize them in any React Native library to create a desktop application that will work completely fine for you, and you will have your own compiler. So comment your responses so that I know what I need to do further. Okay, bye.